I have given the definition of electric field. We are used to that one. Now, electric potential is the energy required to bring a charged body from an infinity. You can see the line going. It means I am going to a very far place to bring a charge back to either point A or point B or point C. So the energy needed, the work done, that will help us to bring a charge from an infinity point to point A or point B, point C, just say to a particular point, is called electric potential. Now, electric field intensity. Intensity is the as strength. How can we determine how strong the electric field is? So we can define that as ratio of force to charge. So ratio of force. So I'm talking about electric intensity E is the ratio of force to what? To charge. Now, let us discuss their relationship. Let's discuss their relationship. There is a great relationship between electric field and electric potential. Why? How? Because electric field with respect to electric potential can be defined as rate of change of, let's add this. Most of the time when you are asked to state the relationship between electric field and electric potential, so we can say electric field is the rate of change of electric potential with distance. That center I have just made, this is the mathematical representation of it. Rate of change, dV, meaning electric potential is changing with what? Distance, where x is what? Distance. So change in potential, change in electric potential with respect to change in distance can be seen as electric what? Field. That's just the relationship between them. That if you want to get electric field, you can find the rate of change of electrical potential divided by rate of change of what? Distance. Do not forget that by bringing a charge from infinity to a particular point, you must have covered some what? Distance. And you are using an energy to do that. So that's why we say we must change that potential difference or electric potential over changing the what? Distance. So that we can get electric field. So note this, I can say the relationship between electric field and electric potential is that electric field is the rate of change of electric potential with distance. The rate of change of electric potential with distance. Which means if you need to get electric field, you just change or find the change in electric potential and find the change in what? Distance. Whatever you get is known as what? Electric field. Now, what is the relationship between the same electric potential and electric field intensity? We can have that relationship using this equals to, we can have that relationship using V is equals to E, I think it's ED, yes. ED, yes. Where this is the electric field intensity. So which means if you want to know this is electric field, so this is electric potential, this is electric field intensity, and this is what? Distance. Now we are trying to show relationship between electric potential and electric field intensity. So if you want to know the relationship between them, you can use this equation. In order to get electric field potential, we multiply electric field intensity by that of what? Distance. So note these two equations very well. When it comes to relationship between electric field 1, electric potential 2, and then electric field what? Intensity. So we are noting these two equations because we are coming back to them. Now the third one, we shall be looking at electrostatic potential energy. Now the word potential energy itself means the energy an object possesses by the virtue of its position at rest. The energy, I have not coupled that definition with electricity now. I am defining potential energy. So it is an energy an object derive or obtain or possess by the virtue of the position of that object at rest. Meaning, the energy an object possess when that object is at rest. For instance, a mango fruit on the tree must have possessed some energy while it's at rest on the tree. And that's why when such a fruit fall on the glass, you can see that the glass what breaks. Meaning the mango fruit is using the energy it has gained while it is at rest to do the work of breaking the what? The glass. That's exactly what we are talking about in potential energy. Energy an object derive is different from kinetic energy. Kinetic energy is the energy an object derive when the object is on what? Motion. Like a flood. A flood can carry a big house. Why? Because as the flood is moving, it has gained so many kinetic what? Energy that it can use to do many things. So it can use it to push a car, can use it to carry a house. But energy an object derived when the object is at rest, is not moving, is called potential energy. Now let us relate that to electrostatic or charge. So when do we say electrostatic? When do we have electrostatic potential energy? We have it when the charge Q obtains some energies at a what? Rest. So we can define it as electrostatic potential energy is defined as a situation whereby a charge Q possesses some energy by the virtue of its position at rest. I tell you the definition again. Electrostatic potential energy is the energy obtained by a charge, not by an object now. The object is now what? A charge. Is the energy obtained or possessed by a charge body Q by the virtue of the position of that charge at what? Rest. Meaning that charge is not moving from one place to another. Let me give you a very good example. When you take the barrel of your barrel means, okay, like in this, and then you rub it vigorously with your air. We call it science study 4, FUR. When you rub this thing vigorously, you can try the practical yourself after watching the video. And then you hold that biro near a very small piece of paper. Very small. I do not say very. You can see that the biro will attract the piece of paper. Now, there is charge in the biro now, and that charge has been acquired in a potential way. Because nothing has moved from one place to another before the charge is obtained in the barrel of the what? Biro. So that charge has gained some energy to carry that paper, and that type of energy obtained by the charge to carry that paper is electrostatic potential energy. So that is what we call electrostatic potential energy. Now, anything charged has some principles which you need to know, because there are two types of charges. I think we have discussed that in the previous class. I have positive charge, I have negative charge. So the principle is that when they look alike, they will repel. And when they look unlike, they will attract. So we can state the principle of charge by saying the principle of charge states that like charges repel, unlike charges attract. So that is about electrostatic potential energy. Now we shall continue in the next class.